Hello again everybody, back with another video. This one I call Very Short Horizons and Strange Shadows, and this is related to the Apollo missions and the moon landing. And I've taken an easy option here, and I've basically resurrected an old video I did back in the days of the James LE channel that got deleted because my brother posted too much truth on it. And I've cut a little bit out and added some extra to it. And the basis of it is to look at the diameter of the moon, which is 2,160 miles. And don't forget, 216 is 6 by 6 by 6. So I wonder why we've got that number. But you'll see from doing some curvature calculations to see where the horizon was, and where it actually is in the photographs, and I'll use a real life example to compare it against, but not on the moon of course, but in a road near me, and you'll see that the horizons are very, very close, which indicates it's not really on the moon. And this one here is the Clanger's planet, which is a similar curvature to the kind of curvature you see. So without further ado, I will break in to the old video, and I have taken some of the less interesting parts of it out, and we'll focus on some key things, including, which everybody else in other videos has highlighted, the shadows and the directions those shadows are going in. So let's get on with the video. First, I'd like to go through and look at some of the curvature calculations for the moon so we can calculate the horizon distance. So this will look at a little bit of maths and how to calculate the ball moon horizon. I've done all this before for the Earth. I've also set up a curvature calculator for the ball Earth, and I've also made one now for the ball moon. So here's our ball moon. We've got our globe moon radius of, here this is a radius, this is a radius, and this is a radius of 1,080 miles. Okay, so here we've got first viewing height of h1, looking to the horizon, and the horizon is basically where your line of sight hits the curve of the ball tangentially. So if you draw a line here through the horizon, it's at right angles to here, it's a tangent, and basically where the horizon is, we've moved from our original position of radial movement of this angle here, alpha 1. Now if we go a bit higher, we can see further, and we get our horizon 2 further away, draw our radius there, and we've moved through a bigger angle. Now you can work out for how many degrees exactly how far you've travelled on the surface of the moon. And the circumference is 2 pi r, so I'll put our pi in, and our 2, and our 1080 for the moon radius, and that gives us 6786 miles. So 1 degree of rotation is 6786 divided by 360, which gives us 18.85 miles of surface travel. So we can work out basically what this arc is for any degree movement here. Now to calculate how far it is to the horizon, we want to calculate our line of sight to the horizon. For h1, that's b1, and for h2, it's b2. Now if we look here, we've got a right angled triangle, and we know this side, which is the radius, and we know this side, which is the radius plus h1. Now by taking the square of the hypotenuse and taking away the square of the adjacent and square rooting it, we will get b1. And this is the Pythagorean theorem basically. Trigonometry, very, very simple maths really. And if we look here for h2, we've got an even bigger right angled triangle, and the same applies. So we can convert feet to miles by dividing by 5,280. So let's take a look. Okay, so B1 here, and we're looking at H1, and H1's 5 feet, so I've had to divide that in this equation by 5,280. 1 mile is 5,280 feet. So if we work all this out, B1 for 5 foot viewing height is 1.43 miles. And if we look at B2 doing the same equation, so this is the square of the hypotenuse, this is the square of the adjacent, and we're square rooting it because that all this equals B1 squared. So we square root it to get B1. And if we do it for B2, we get 2.02. And if we do another one and go to B3 and do a H3 at 15 feet, that goes out to 2.48 miles. Now it's a lot further on the ball moon because the radius is 3959 instead of 1080. But 1.43 miles from a 5 foot viewing height is a pretty significant distance. Now the purists might say, well, the distance on the surface is this arc, it's not this straight line, but this is such a low angle and it follows this so closely that over the distances we're talking about, it's the same. And you can calculate this because you know this side here and you know this side here. So you can calculate using the cosine what alpha 1 is, and then you can multiply whatever degrees that is by 18.85 to give you the distance E. So let's just do that for the 15 feet just to show you. So here it is, here's the calculation, and it comes out to exactly the same, look, 2.48 miles. Now I've put all this into a curvature calculator. It also calculates the distance hidden past the horizon at various distances, but we're not really interested in that for this video. So here we go. So height of 15 feet, I've put a distance away of 10 miles of the object we're looking at here. It doesn't really matter, I could have just left it blank, but it gives us the horizon at 2.48 as we've just shown, or 4 kilometers. If you wanted to know what the distance hidden by the horizon, under the horizon basically, of an object that's 10 miles away on the moon, it's at 15 feet viewing height, it's 138.3 feet. And we'll take another look at one. So what I've done here is I've put in the approximate height of the cameras that the NASA astronauts were carrying on their film setup, on the moon. And I've put a distance away 10 miles just so we can get a figure here. But we can see here at 4 feet, the horizon should be at 1.28 miles or 2.1 kilometers. And just for your information, the curvature loss, if an object was 10 miles away on the moon, if there was a full moon, and we were viewing from 4 feet, would be 186 feet. So, taking that in mind, this is a photograph taken by a camera held by an astronaut, about 4 feet viewing height, and he's taken this picture here. So whether this is Armstrong or it's Aldrin, I have no idea, but I do know it's Apollo 11. So this horizon here, look, is meant to be 1.28 miles away because the Sea of Tranquility where it landed was meant to be relatively flat. So we'll see all these little stones here on the floor. You can see them all here, look, along the horizon line. Now bear in mind, a stone at 1.28 miles, which is 6,760 feet away, would appear to be 1125 times smaller than if it was 6 foot away. So see this one here? What's this? Maybe here this one is of this one. Maybe a third of the size. These would have to be giant boulders all along that horizon line. Giant boulders. Yeah, bear in mind if this was 6 foot away and this was a couple of inches, it's going to be 2,000 inches by the time it gets to there. And also we've got the shadow, look at this shadow here. The shadow is almost going to the horizon and you can see all these stones here. So basically this is fairly clear to me that this is not on the moon. It's staged, it's a set. And to give you a little bit of perspective to what it would look like on the Earth that we're familiar with, this is a road that I walked down many times, and I know this hedge here, and I've reached up to the top of it, or as high as I can, and my reach is about 7'6" to my fingertips, and my hand is maybe 4 or 5 inches short at the top of this. So this is around 7'6" to 8 feet tall. So what I've done here is I put a guide along where the hedge here is to about 6 foot something, 7 foot tall. And this guide here is where a critical point of the lunar lander will be. So I've cut out a lunar lander. I'm going to put it into this little grid here, and I'm going to make the astronaut this height, and I'm going to slide it along. So let's just go back and show you what I mean. See this support here? It's level with the horizon. This is coming forward, so it's slightly below, but this one's level. Okay, so I've put a grid line on that diagram. So let's go back to it. Now let's slide the lander across. So this is probably a good scaling, because see the astronaut here? Now what you want to show you is this road is 0.4 miles long, and it drops about 5 feet from the top to the bottom. But look where this is. Yeah, look. It's here. It's not. And the horizon would be, if I could see and there weren't trees here, would be somewhere up here. So do you see that it looks nothing like this? And can you imagine trying to see, you could see a stone on the road here. You imagine trying to see a similar stone down there. It would be virtually impossible. This is just zooming in to show you where the bottom of the road is. You can just about see a van there. You can see it much better here. Okay, so it's not looking good, is it? So here we go again, just to show you that diagram. Does that look like that 0.4 miles? Bear in mind that 0.4 miles, and that road is only a third of where the lunar horizon should have been. A third. And look at it. So looking at this another way, I've taken all the other lines off, and I've put a line here to where the bottom of this road is, which is 0.4 miles from here, and I've put a line at the bottom of the astronaut and the feet here, and I'm going to bring over an image from Apollo 8. So let's bring that image over, make sure I keep it in line. So you can see that's where obviously I got the lander from, so I've done pretty well there, look. And take a look. I can't move anything with the mouse or anything because I'm holding it in that position. But take a look at the horizon difference between what we're seeing there of the moon. Do you see? And the bottom of that road that's 0.4 miles away. So was it on the brow of a hill? Was it always on a brow of a hill? Was it on a flat sea of tranquility? But that horizon isn't right. That horizon is probably pretty good for a film set, but in reality, look where it is. So that's just another way of looking at it. So this is the lunar module for Apollo 11, and I think when they first started this, they just didn't expect people to be able to work out where the horizon was, and even question that it was fake. But there was a film called Capricorn 1 where the astronauts were told at the last minute that they couldn't actually do the mission through the fact it was impossible or something. But these astronauts escaped and told the world. But not going to happen here, because these guys are Freemasonic deceivers and they're all part of the game, and they were well bought into it before they even started. But can you see the similarities? Look, yeah. The horizon, does it look very similar to this? And this is a film set, guys, yeah. And here's the astronaut, similar size to this one. So there you go. Maybe that's the truth, Capricorn 1 in plain sight. Just another few photographs. I think this is old Buzzy, Mr. Freemason coming down his ladder. But look at that horizon, guys. Look at the bits on it. Yeah, 1.2 miles. My ass, 1.2 miles. Again, another photograph, Apollo 11. This time there was something that took my attention here. I blew it up originally to show that these boulders went to the horizon, but there's all kinds of stuff. I don't know what this is. This is where the horizon is. But what's this look like to you? Now, it could be just a coincidence, but that looks a bit like a dog to me. And I wouldn't put it past the whistleblowers to have done that. Okay, so here we go with another photograph, famous photograph. Look at the horizon, you can see all this detail, 1.28 miles away, no chance. This is a reflection here, and we'll have a look at that to show you what it's like from the other side. So we've got the module taking the shadow virtually to the horizon. I have no idea what this is. And we've got the shadow of the leg here and the shadow of the astronaut. It doesn't look very convincing, this shadow, but there is a lot of distortion in that helmet. Here's another one. Just take a look at that. Look at the rocks right the way to the horizon. Well, how far is that? 50, 60 feet? I'd say 50, 60 feet, maybe 70 at the most. So let's say 50 to 70 feet on the film set. Here's another one where things look even worse. You can see stones on the horizon. It looks even shorter here to that horizon. 1.2 miles. My ass. Another one, it's virtually the same photo but with an astronaut in. I've just put an arrow showing these stones on the horizon. Just another photograph of Apollo 11, not much of an horizon here. This is the back side of it. I don't know whether this is meant to be vertical, whichever is casting a shadow next to the astronaut. If it was vertical, then there's no way with a distant sun these lines should cross, but I don't know what this is. I just put these on because you'd expect if these were at the same kind of distance, looking this way, they shouldn't intersect before the horizon, but they do. They intersect not far, maybe 20, 30 foot past the astronaut. Another one of Apollo 11. This is old Buzz with some experiments apparently, but look at the horizon here. 1.28 miles, no chance. There's another one, very, very short horizon, but now we've moved on to Apollo 12, and this is the astronaut coming down his ladder. And here we've got the window, and in this window, I assume this is meant to be the reflection of the surface of the moon. But when we look at that, what on earth is this? Does that look like the surface of the moon to you? Or has somebody just hairbrushed it in and done a bad job? I'd go for the latter personally. Another one, Apollo 12. Not looking good for 1.28 miles there. Another one here. And I've taken the photograph in the visor, as you can see. Very, very short horizons involved here. Another Apollo 12. Short horizon, but I'm not sure what this is. I've blown it up here, but is the astronaut taking the photograph? I have no idea what's happened to his shadow. Or whether there's a big drop here or what, but looks like he's bent over double here. I have no idea what's happening. It's very, very odd, that one. Okay, just another Apollo 12. Again, we can see stones along the horizon line, and it's meant to be 1.28 miles away. Another one, Apollo 12. This time the shadow from the lander is touching the horizon. 1.28 miles, no chance. And to sum up Apollo 12, this is meant to be the original Apollo 12 command module. And this photo you can find on the internet. It comes up quite quickly. And a little lad standing dead centre of it with a big 33 for masonry, telling you that this is a hoax, basically. Now, Apollo 14, this is interesting. This was a screenshot from a video, and it was a cine camera of the guys coming out of the lander. Can't remember what the lander was called on Apollo 12. Great big shadow. Horizon doesn't look too far away. And again, 1.28 miles horizon doesn't look good. Now, bearing in mind Apollo 11, 12 and 14 were meant to land on fairly flat terrain, which kind of gives the game away on the horizon front when you've got a film set and you're trying to mimic a large area. And maybe nobody calculated the lunar horizon from 4 feet should be 1.28 miles. But we'll see they came up with a remedy to make it easier to confuse people or to deceive people by putting mountains around the perimeter of the views on Apollo 15, 16 and 17. Now let's take a look at an area that's been highlighted in many videos in the past, questioning the validity of the photos of Apollo on the moon. And that's the shadows. So let's take a look at shadows. So here we've got a line of poles, and here we've got shadows running across, and the nice photo of the birds sheltering from the sun in the shadow there. And if we look, we've got parallel shadows. Now perspective for things that are close on in the line of sight will make these lines compress as we move backwards, yeah? But they should stay parallel, and as we can see, they essentially do. Now on this photograph, we've got a line of sight here, so this is in line with this line of sight. So we should expect, with a distant sun, for the shadows to be parallel. But they're not. They're not parallel at all. Now, to me that means diverging shadows on a line of sight like that. I can understand if they're off the line of sight and there are different angles, perspective can do all kinds of things, but these shadows are diverging, and to me that means a close studio light or a model light, or however you want to look at it, but that just does not look right. So we've got Apollo 14, there's some photographs here of the horizon. Again, shadow is a good way towards it. We've got a rock here, pretty close to the horizon. Is that 1.28 miles away? Here we've got another very close horizon on Apollo 14. You can see so many features and little stones at 1.28 miles. Bear in mind, they're going to be well over 1,000 times smaller at 1.28 miles than they are at 6 foot away. Again, Apollo 14 showing a very, very close horizon, maybe 30, 40 feet away. This is just showing you on Apollo 15 that there's no horizon difficulties here because there's a backdrop, probably painted in. I don't know how it's been done basically, but featureless mountains, smooth featureless mountains, doesn't look real, just doesn't seem to have any 3D substance in it at all. And showing you again surrounded by hills, but very, very straight lines involved. You can draw a line right across here like that. So again, strange looking photo. And this one I found of Apollo 16. Again, we've got some shadows. There's a shadow from this rock running here. We've got the shadow of the astronaut and a shadow of the lander. Now, this is all in the same line of sight. So you would expect the shadows with a distant sun to be parallel. So the reason it isn't, I would say, is because it's studio lighting. Apollo 17, just showing again, you can't look at the horizon because it's got mountains in the backdrop, but you do see a discrete colour change here all the way across and featureless, two-dimensional looking mountains in the background. It does look like something that would be painted on to me. Okay, so impossible horizons. I know they didn't go to the moon. I'm just trying to prove with little bits here and there to show they didn't. And basically, yeah, Capricorn 1 was probably something that gave the game away. And here we go, look. Similar looking horizon distances. And basically, that's all from me. So that's the end, guys. Thanks for watching. Thanks for listening. And it's a film set. Bye-bye.